Geometry, conditions for parallelogram. So we will be discussing under what condition is quadrilateral is parallelogram. We're going to go through them one at a time, right? Uh, in a previous video, we talked about given a parallelogram, what are the properties of it, right? But the converse of those statements is not necessarily true. So we will be spending this particular lesson talking about the converse of the previous lesson's property is indeed true, and those are the conditions for which the quadrilateral is proven to be parallelogram. The first one is if the both pairs of opposite sides are congruent of the quadrilateral, that is, then it has to be parallelogram. The second one is if one pair of the opposite sides are both parallel and congruent, then the parallelogram. So what I want you to do is I want you to do the T proof or two-column proof for this one. And for this one, just think it out, see how you would do it, and you should be able to do that on your own. Okay. So for example, if this is given, it's a bit of a review here, guys. That is a given statement. If given, then we prove this. Okay. Once we prove it, this is the conditional. This is the conditional part, right? And we would be able to use that as a theorem. So given information in this case, and using the diagram that was given to us, we say that the AD is congruent to CB. Now, some of you might have put that as BC, like AD and BC. But if you sort of think about the triangle we're going to be drawing, guys, it has to go the other way if we were to respect the correspondence of the sides, right? So I'm sort of anticipating that, but technically it is not wrong to call this segment BC, right? But it's the way I'm writing it, it's much better habit for us to adopt. Given that information, we're supposed to prove that the ABCD is a parallelogram, right? And why don't you put the T proof or T chart proof or a two-column proof, right? Over here. And it should take about 7 to 8 steps, depending on how you write them out, right? And over here, you don't have to sort of like write it out if you don't want to, but it's a good idea for you to walk through the argument, and you should be able to write it out for you guys, okay? If you have difficulty writing this out on your own, then you should come see me during office hour, okay? All right, guys, why don't you guys go ahead and stop the video and work on these two problems, guys, okay? All right, guys. So we're back uh, to this, and here it is. What we did was we needed to put the draw the arc segment AC because through 2 points there exists exactly one line. Obviously, we had to start with the given information right here, guys, right? And then we note that the AC is going to AC by reflexive property, and that tells us that this and this triangle are congruent because of side-side-side triangle congruence theorem. So we know that the angle BAC and CDA, right, are congruent by CPCTC. And the angle DAC and BCA also by CPCTC. So by putting this together, we have less lines to write out. And we also note that because these two are congruent, these two must be parallel by the converse of alternate interior angle theorem. And similarly, AD and BC must be parallel because these two angles are congruent for the same reason right here, guys, right? Then we know that the ABCD is a parallelogram because by definition, a parallelogram. For the next one, I didn't bother writing it out for you guys, but here it is. I'll walk you through this right now. So we're given that this and this is both parallel and congruent. Okay, let me actually, you know what? Yeah, let me do that from scratch, shall we? All right. It might be easier if I do that. So we got A, B, C, D is given to us, and we know that these two are parallel and congruent, right? Then how could we make sure that it's parallelogram? Well, guys, by definition, if you could show that these two are parallel, by definition, this will be parallelogram. Or we could use the previous idea over here, because if you could show that, now that this has been proven, if you could show that somehow that these two are congruent, then we know that if both pairs of opposite sides are congruent, then it must be congruent. So that's given to us, right? So first thing we should do is draw a uh, segment. Why? Because through any 2 points exists exactly one line. Okay, given that information, because they're parallel, we know that, and let's start with using different color actually. These two are congruent. And by reflexive property, these two are the same. So for that reason, we know that the triangle ACD is congruent to triangle CAB, right? By side angle side, because of side angle side triangle congruence theorem, right? Because we know that the AD is congruent to CB, right? AD is congruent to CB, first and third, because of CPCTC, corresponding part of the congruent triangles are congruent. Well, now we know we have both pairs of opposite sides are congruent, right? So we can now claim that quadrilateral ABCD is a parallelogram, because if both pairs of opposite sides are congruent, then quadrilateral is a parallelogram. So it's a good idea to use the theorem that we just proved, just so that we get a good practice out of it, right? Now, if you wanted, what you could have done instead of this step over here, you could have said that because of these two angles are congruent by CPCTC, then AD and BC are parallel. And then this would change to the definition of parallelogram. All right, guys? All right, guys. So that is it. Let's go to this. In this particular case, we're trying to show that the both pairs of the opposite angles are congruent. That's given, right? So in this particular case, we're given that the measure of the angle A and C are congruent, which by extension means that the measure of the angles are congruent, right? And we know that the angle D is congruent to angle B, or the measure of the angle D is equal to measure of the angle B. Given that information, right, we're supposed to show that the quadrilateral ABCD is a parallelogram. And how would you do that, guys? Right? So what I'm going to do is give you a little bit of time, but the hint is for you to, once again, draw a uh, auxiliary line, right? And just go from there. Okay. Okay, guys. Well, why don't you guys go ahead and stop the video and work on the problem, guys. Okay. All right, guys. So we're back, and let's go through what I did. Okay. And you could see all the steps in one. Basically, what I did was that we already said that the angle D and the B are what? Equal to each other, right? I just called it S, right? And I called this X and Y. I called this P and a Q, right? And we know that given that this triangle and this triangle, the sum of the interior angles 180 degrees. Bingo, right there. Because they're both 180, they're equal to each other. Boom, right there. And I could subtract S from both sides. I'm left with this, right? And then let's me group this together, guys. And then from that point on, I just moved the y to this side and q to this side. The reason why I did that is I did that like much later. The first thing, and then on the right hand side, what I said was that these two are congruent to each other because we know that the angle A and angle C are congruent to each other, right? So x plus y is equal to q plus p. Now, when I move that into this expression and put it over here, guys, look what I see. Exactly. So if I add these two, the y's cancel and the q's cancel. So 2x equal to 2p, which means that x is equal to p. So what we just suspected, x and p has to be equal to each other, right? And because they're equal to each other, by converse of the alternate interior angle theorem, AD and BC are congruent. Similarly, in this particular case, the second chase around, instead of adding, we subtract the two equations that we had earlier. And then the x's cancel, and that becomes y minus y gives you 2y. Similarly, this becomes 2q, which implies that the y is equal to q by the converse of alternate interior angle theorem, because these two are the same, right? They're making this shape right here. These two must be parallel by the converse of alternate interior angle theorem. Now that both pairs of opposite sides are parallel, over this way, we know that both pairs, quadrilateral is a parallelogram if both pair of opposite sides are parallel by definition of parallelogram. All right, guys? And I would classify this as a paragraph proof. Paragraph proof is having a bunch of sentences, and we can make an argument that this is a mathematical sentences, right? All right. Uh, to be honest with you guys, there are more paragraph proofs in a math book than a two-column proof. The two-column proof was sort of designed to help you think through the problem, but ultimately later on to organize your thoughts, right? But moving forward, though, this is the way we usually do things. Okay. All right, guys. So we are here to do a couple more. If one of the properties of parallelogram was that the diagonals bisect each other, right? And if the diagonals of any quadrilateral bisect each other, then is it a parallelogram? That's what we are here to prove. And we have, that's right, a guided proof over here. So it's your job to figure out what to say over here and then to write that over here. Okie dokie. All right, guys. And then you have an example here to do. Why don't you give it a shot and stop the video and work on the problem, guys. All right. I'm going to assume that you have finished working on it, and here it is. Okay, sorry about that. I forgot to write a bar over here. I hope I changed that in your notes. So we know that the AE is congruent to this CE and BE is congruent to DE. Well, that's given information, isn't it? And then we know that the angle AEB and CED, so these two and these two are congruent to each other because of vertical angles are congruent. And we know that triangle AEB is congruent to CED and, well, because of side angle side. Similarly, angle AED is congruent to CEB for the same reason, side angle side triangle congruence theorem, guys. Okay, and we know that because of that, AB, because this triangle and this triangle are congruent, these two are congruent. For a similar reason, these two are congruent by CPCTC. Well, we using the very first theorem that we learned in this particular lesson, we know that the ABCD is parallelogram because if the opposite side of quadrilaterals are congruent, then we know that the quadrilateral is a uh, parallelogram. All right, guys. So that's it. And the examples that we have over here, we know that if show that the quadrilateral is parallelogram for given value of the variable. Well, let's see if it is, right? If x equal to 7, y equal to 4, plug in all the values, and we find that the BC is 21 and AD is 21. So the opposite sides are congruent. good. And then if y is equal to 4, plug into these two, we find out that AB is 16 and CD is 16. Yes, it is. So we could say that the quadrilateral ABCD is parallelogram because both pairs of opposite sides are congruent. And this is the minimum amount of work that I like to see. Similarly, by plugging all the values in here, guys, I found that the angle F is 118 and angle H is 118, right? So you gotta be careful with the arithmetics, guys. And then plugging in the other values, 4.5, I just put it as 9 over 2. I think it's easier for me to do that way. And angle G and E are both 62 because of that. Well, we know that if both pairs of opposite angles are congruent, then we know that the quadrilateral must be, therefore, um, parallelogram. All right, guys. Here's your turn. Do me a huge, huge favor and work on this one, guys. Okay, stop the video and work on the problems. All right, guys. I'm gonna assume that you already did that, and here is the answer. And if you have trouble understanding this one, we will go over in class. This is very similar to the example, so it should be fairly doable. All right, guys. I will see you in the next video. All right. Have a good night.